Welcome to my channel. In this video we're gonna talk about the power rule, which says the derivative of x to the power n is equal to n times x to the power n minus 1. So we bring this constant down, then we subtract 1. As a special case, the derivative of x is equal to 1. Let's cover some examples. First, I'm gonna cover basic examples like the derivative of x cubed is equal to 3 is a constant, we bring it down, then we subtract 1. The answer is 3x squared. Another example, the derivative of x to the power negative 3. This negative 3 is a constant. We bring it down, then we subtract 1. The answer is negative 3 times x to the power negative 4. The derivative of x to the power 1.7. This 1.7 is a constant. We bring it down, then we subtract 1. The answer is 1.7 x to the power 0.7. The derivative of x to the power pi. Pi is a constant. So again, we bring it down, then we subtract 1. Same thing for x to the power e. E is a constant. We bring it down, then we subtract 1. Let's cover another example. Let y equals 1 over x to the power 4. Find dy over dx, the derivative of y. Let's recall the power rule. The power rule says the derivative of x to the power n is equal to n times x to the power n minus 1. What I have here is not as x to the power n. It's 1 over x to the power n. We need to fix it. From basic algebra, we know that 1 over x to the power n is the same as x to the power negative n. We can use it for sure. So in step number 1, we rewrite this function as y equals x to the power negative 4. Then we find the derivative dy over dx equals, we bring this negative 4 down, then we subtract 1. The answer is negative 4 times x to the power negative 5. This is a good answer. Also, we can write it as negative 4 over x to the power 5. Let's cover another example. Let y equals the third root of x squared. Find y prime. dy over dx or y prime is the same thing. Different notations for the derivative. So again, the power rule is the derivative of x to the power n equals n times x to the power n minus 1. So it should be written as x to the power n. I don't have it in here. But we know from basic algebra that the nth root of x to the power m is equal to x to the power m over n. So in step number 1, we rewrite this function as x to some power. In this case, we write it as x to the power 2 over 3. Now we can apply the power rule. So the derivative y prime is equal to, we bring 2 over 3 down, and then we subtract 1. 2 over 3 minus 1 is equal to negative 1 over 3. This is a good answer. Also, we can write it as 2 over 3 x to the power 1/3, or we write it as 2 over 3 times the third root of x. Let's cover another example. Let f of x equals 1 over the fifth root of x cubed. Find f prime of x. So in step number 1, we try to rewrite this function as x to the power n so that we can apply the power rule. We can write the fifth root of x cubed as x to the power 3 over 5. And then we bring this up as x to the power negative 3 over 5. Now we can apply the power rule. F prime of x is equal to negative 3 over 5. We bring this constant down. Then we subtract 1. Which is equal to negative 3 over 5 x to the power negative 8 over 5. This is a good answer. You can also write it as negative 3 over 5 x to the power 8 over 5, or negative 3 over 5 times the fifth root of x to the power 8. This is a good answer, and this is also a good answer. Thank you.